Okay, this is the second half of the notes for section 3.7, and in 3.7 we're looking at properties of quadratics. So we talked about the domain and range. We've also talked about end behavior. Now we're going to talk about where the function's increasing and decreasing, and also where it's positive and negative. So we here are asked to describe where the equations are increasing and decreasing. And it will be helpful for us to look at a graph of this. So we're going to graph this. Here we could sketch a graph by hand. We could put it on the calculator. I'm going to use Desmos because I think it gives the prettiest graph. So I already have over here where I've graphed this equation. This is f of x equals x minus 3 times x plus 2. I also added this right here that gives me a point on the graph, just so I can illustrate something here. So whenever we talk about increasing or decreasing, we are always talking about what the function is doing from left to right. So right here for this graph, I'll demonstrate with this point. As we move from left to the right, we see the point is decreasing. That y value is decreasing until we get to this point right here, and then our point increases. So for quadratics, the place where the function switches from increasing to decreasing or decreasing to increasing is going to be your vertex. And on this graph right here, our vertex is at -1, -16. Now, whenever we describe where a function is increasing or decreasing, we are only giving the x values. So for this particular case, my function is decreasing from way over here at -infinity all the way up until this point, and we're going to get the x coordinate, which is -1. And then the function increases from -1 all the way for all the x's all this way to positive infinity. So the way that we can write this is we can say that the graph is increasing. I like interval notation from this. From -infinity to -1. I always use a parentheses there because at that minimum point it's really neither increasing or decreasing. Or you could say this would be the same as x is less than -1. So for any value less than -1, oh, I have this backwards, that is not increasing, I should say decreasing. Okay, so from -infinity, move this back over here, -infinity all the way up to an x coordinate of -1, we see that the function is decreasing. For the increasing, this is going to be from -1 up to positive infinity. Or I could say x is greater than -1. That would mean the same thing. Okay. All right, let's graph this next one. 8 plus 7x minus x squared. So if we graph that real quick here, let's get rid of this. Y equals 8. So what was it? 8 plus 7x minus x squared. And let's zoom out a little bit so we can get a better graph here. So if I'm looking here at this function increases all the way up here to this maximum point, and then it decreases. If I find that maximum point, you could use this, we know several ways to find that maximum point. Desmos gives you a beautiful picture here. We see that's at 3.5, 20.25, but we only care about the x values for this. So we are increasing from -infinity up to 3.5, and we are decreasing from 3.5 to infinity. So for increasing, it is -infinity to 3.5, or I could say x is less than 3.5, and the function decreases from 3.5 to positive infinity. Remember, always x values for this. We could also say that would be x is greater than 3.5. Okay, let's look at this next one. -x squared plus 5x plus 7. So -x squared plus 5x plus 7, and that gives us this graph that we see here. This time we have a vertex at 2.5, 13.25. We're only worrying about the x-axis, the x values. Like if I put x equals 2.5 here, this splits the graph. So anywhere from negative infinity all the way up to 2.5, we see the graph is the function is increasing, and then anywhere from 2.5 to infinity, the graph decreases. You don't ever give y values for these. So you're increasing from negative infinity to 2.5, or I could say x is less than 2.5, and then decreasing from 2.5 to infinity, or x is greater than 2.5. Okay, now we're going to look at something that's a little bit different. Telling where a function is positive or negative is different than increasing or decreasing. A function can be increasing but negative, or decreasing but positive, which seems a little bit backwards. But whenever we're talking about positive or negative, we are talking about the value of the y-coordinate. So if our y-coordinate is positive, then that means the graph is going to be above the x-axis. If our y-coordinate is negative, that means the graph is below the x-axis. So, for example 11 here, we have this picture. It doesn't really tell us what the function is, but we have a picture. We want to know on what intervals is the function positive. So, if I just highlight it here on the graph, the function is positive here whenever it is above the x-axis. So, in this case, we would say that the function is positive from negative 5 to positive, from negative 5 up to, I believe that's positive 3, right there on the graph. Or, if we're using, if we want to use inequality notation, negative 5 less than x less than 3. Okay, we also want to know the intervals where the function is negative. So, if I highlight that here, we see we're below the x-axis here, and we're below the x-axis here. You're always given y values. So this is everything less than negative 5. I can write it like this, negative infinity up to negative 5, or if I wanted to, x is less than negative 5. And we have another place where we're positive, where we're negative here, from 3 to positive infinity. So 3 to positive infinity, or x is greater than 3. So you can either give this as your answer, or you could give this as your answer. You've got two sections there. Remember, you're not giving y values. I can't tell you how many students will put 3 to negative infinity because the y is going to negative infinity. But we're only talking about x values here. So if you think of drawing in a vertical line right there at 3, we are looking at the x values. So right here, our x values are 3 and more. So 3 to positive infinity. Right here, we always have to start with the lowest, so we go from negative infinity up to 5. We are not including the negative infinity here because it goes down, but because we start over here at negative infinity. And then also ask, for example 13, on what interval is the function decreasing and positive? So I'm going to erase the highlights that I have here, get rid of this. So let's just kind of overlap what we've got here. So the function is going to decrease here. Okay, on that right hand side, once we get past the vertex, our function is decreasing there. However, it is only positive on that section right here. Okay, right here it's going to hit the x-axis, and here we're decreasing in negative. So we are looking from this point down to this point. Now remember, we are only given the y value. So like this is negative 116. I'm sorry, we're only given the x values. And this is 3, 0. but whenever we give the answer, we're just going to say from -1 to 3. Or if we use inequality notation, -1 less than x less than 3. We're only given the y values. So we're given, I'm sorry, keep saying that backwards. We're only given the x values. So we're looking at splitting this graph off here, where we're only talking about what's in between these two bars. Okay, so for example 14, we're supposed to tell the intervals where this function is positive and negative. So I'm going to actually do this one where I sketch a graph on my own, because I know my x-intercepts here, if I just set this equal to 0, will be at x equals -7 and x equals 4. So if I sketch myself a graph, over here at -7, I have an x-intercept. Over here at +4, I have an x-intercept. And I also know this function is going to be a happy parabola, smiley face, because our x squared is positive, so it's going to open upward. So my graph will look something like this. And so if we look at this graph, we're looking for where the graph is positive and where it is negative. Okay, so positive means the graph is above the x-axis. So that's here and here, top half of the graph. We're given x values. So we are going from -infinity up to -7. So from -infinity up to -7, and also from 4 to infinity. And on this section right here, let's get our highlighter again. On this section right here, we are below the x-axis. So from -7 to 4, our function is negative. This next one, we're supposed to tell where the intervals were, where this function is positive and negative. Let's graph this one in Desmos. So we have 24 plus 5x minus x squared. 24 plus 5x minus x squared. And we'll zoom out a little bit here. And if you click on the graph here, it'll show you that you have a x-intercept at -3 and another one at 8. So if we just sketch ourselves a little graph here, we've got -3 and +8, and this one is upside down. So for this one, negative is right here. So we will have negative will be from -infinity up to -3, and 8 to positive infinity. For positive, the graph is positive in this middle section right here. So the graph is positive